Okay, so in the last module, we introduced the idea of arrays, which would be collections of variables. And so we learned that we can declare an array of any data type. And if we, say, declare an array with 5 elements in it, we really are getting 5 distinct variables with 5 distinct names. But the name is formed by a common name for the array plus an index. And the index starting at 0 and going all the way up to 1 less than the overall size will allow us to numerically access each individual variable. But one of the things that we did in the last module was we looked at, or we read in from the user all 5 numbers if we created an array of size 5. And put more generally, we didn't really distinguish between the overall size of the array and how many numbers we actually used. So if we declared an array of size 10, we sort of assumed that we were going to use all 10 of those variables or all 10 of those elements or slots in the array. And the reality is that actually is very rarely the case. More often than not, we will create an array in advance of knowing exactly how many numbers or how many variables we'll actually use. And again, this is more often because the user is maybe entering in a list of numbers, and they might enter 5, they might enter 10, but maybe there's a maximum of 20 numbers. So arrays don't change size. Once we create them, we can't change the size of the array, so typically we declare an array that's big enough for sort of the worst case scenario, the most numbers we would actually require. So when we create an array, really what we're doing is we're specifying the capacity, the maximum number of variables we can use, but it really does not mean we have to use all of them. We can certainly consider the array partially filled, and that's the name of this module. But to be able to do that, we need to use a separate variable, usually called count, but it doesn't need to be called count. We keep track of a separate variable that represents the number of elements that we have used within the array, the number of elements that we've assigned a value to. So let's look at this. Let's suppose we create an array of size 4. So we've got our typical array structure in memory. We've got index 0, 1, 2, and 3. Obviously index 4 would be a 5th element, and we only have 4 items in this. We have only 4 variables within this array. So I've injected a new variable called count, and I want to point out that there's nothing magically sort of tying my array to count. They're not connected to each other. They don't really have any relationship in terms of C++, in terms of the computer. It has no idea that count actually represents the number of things in my array. This is all a bookkeeping job by us as the programmer. We are going to use count to represent how many numbers we've filled into this array. So initially we would put count at 0 because we haven't added anything into the array. We just created an array with nothing in it at all. Now, if we take and we try to put the number 14 in here, notice we could have just said my array 0 equals 14. That would have been fine. That would have put in 14 here. But instead, I'm making a point of using count because eventually I'm going to turn this into a loop. So count is currently 0 when we hit this line. So my array count equals 14 puts 14 in the 0th element of my array. And then, sort of lockstep, I put count plus plus. So the count plus plus tells me now there's 1 element in the array. Count plus plus is also telling me another thing. It's telling me where the next element's going to go. Right? So it's sort of simultaneously, it's telling me how many things are already in the array. It's also telling me where the next item goes. Element number 1 is the next free slot in this array. When I do the same thing again, and notice this time I simplified the statement just a bit. I put the count plus plus within these brackets. And remember, the count plus plus, the plus plus part happens after the rest of the statement. if I had written myArray plus plus count rather than count plus plus, that would have done something very different entirely. That would have incremented count first and then used that new count variable in this assignment. But I didn't do that. I said myArray count plus plus equals 9. And that does exactly the same thing as this statement does. It puts 9 into myArray 1, and then after it does that, it increments count. And again, we notice that count represents the number of items and the next slot. Simultaneously, it gives us both pieces of information. Continue doing the same thing, and now of course you can start to see how this could certainly be a loop, right? If we use count to always represent the number of items in the element, we can just do this myArray count plus plus equals something. And of course these numbers don't need to be literal values, they could be inputs from the user. We could read a value from the user and place it into the array. Keep going, myArray count plus plus equals 13. Now recognize of course that now count is 4, telling us that there's 4 elements in the array. Count is telling us the next slot would be 4 over here, but remember now we don't have a slot 4. So there would also have to be some logic inside of our program to make sure that we stop doing this, to make sure we stop adding to the array once count becomes equal to the size. Because once count becomes equal to the size, or the capacity, we have as many variables as we have room for. All right, and that's going to be important that we keep that up. All right, so let's investigate this with an example. I want to write a program that reads up to 15 numbers from the user. And I'm just going to ask the user for numbers until they type in -1. Once they type -1, I'll be done. I won't print out, I won't read in any more numbers. I also have to make sure that if they never type -1 and they type in 15 numbers, that I don't let them type in a 16th number. Right? I need to make sure that I check the bounds of that array and make sure that the current count doesn't exceed the size. As a second step, and I'm going to come back to this, I want to have the user be able to ask to see whether a particular number is present in the array. And that's basically a search. I'm going to search the array for a number, and I'll print out yes or no, or maybe I'll print out how many times that particular number appears in the array. But I'll do that as a second step. My first step, I really want to just concentrate on reading these programs, and maybe I'll just print reading these numbers, and maybe I'll just print the numbers out after the user's done. Okay, so my include statements here. And I'm declaring my array, and again, it was up to 15 numbers, and I'm using integers, up to 15 numbers, and I want to keep track of a count variable, and I'll start that as 0. So that's always going to represent how many numbers are in the array and also where the next element should go. And I'm just going to write a do while loop to wait for the user to type in -1, and we'll deal with the size in a second. So while and I have to figure out while the user doesn't type -1, but I have to figure out how to actually express that, because every time we ask something from the user, notice we're going to read it into a different location. We're going to say cin, but we're going to read it into a count. Right? So a count is a variable. A count represents the element where the next number should go in. And then we would do count plus plus. And we could, of course, just combine it. We could say a count plus plus, but I'll leave it like that. So if we think about how this program is going to work, every time if the user types in a first number, all right, it'll go into count 0. The second number will go into count 1. The third number will go into count or A2. But count keeps incrementing each and every time. Right? So we need to figure out whether the user typed -1. If we just say a count equals, or while a count is not equal to -1, that actually is not going to work, because when the user, let's say the user types one number in and then types -1. Right? So the first number comes in, it'll go into A0, count will go up by 1. Right? We'll check to see whether or not a count is not -1. But notice we're not checking a 0 the first time around that loop. We would be checking a1. And no, we haven't written anything into a1 just yet. The first number that went in was just went into a0. Right? So this is sort of an awkward scenario. We'd have to do something like this. We'd have to check to see whether a count -1 was actually not equal to 0. That could work. And afterwards, maybe we'll just print this out and say print I equals 0. And this is just our standard printout statement, our standard loop to print out the values within the array. Cout. So let's say element I and AI. So we'll run this, and there are a few flaws in this program so far, and I just want to demonstrate each one. So let's run the program, and I'll start entering in some numbers. And of course, notice that once I type in that -1, it stops, but my printout's not all that great, because my printout is printing the 5743. It's printing out the -1, which the -1 is a sentinel value, and we've called it a sentinel before. But now notice that the sentinel value actually was in the array. It was at slot number 4. The other thing that's a problem here is that afterwards, we continue to print out all this stuff at element 5, 6, 7, 8, which is really just a bunch of garbage. Right? So we didn't really pay attention to our count variable. We kept track of our count by adding it into the actual array. But we print it out all the way up to 15. Right? So the first lesson that we want to see here is that we go through the trouble of keeping track of how many numbers we placed in the array. We need to honor that. We need to remember that we've only put count number of elements in the array. So let's do that. Let's change this to count. I'll put in the same numbers, 7, 4, 3, the -1, and now notice we get our numbers and we stop at element 4. If I was to run this again and just type in a bunch more numbers, of course we'd print out as many numbers as I typed in. I'm still not particularly happy about the -1 here though, right? Because the numbers that I typed in really shouldn't have included the -1 when I printed that out. The -1 just indicated that I wanted to stop. So under normal circumstances, I wouldn't want that sentinel value to actually be inside the array. So to fix that, it's a little tricky, because once we read the -1 in from the user, it's there. It's in the array. There's no getting it out. We can't erase it. The only thing we could do is maybe not print it. We could change this to count -1. So now if we ran this again, 5, 7, 4, 3, now we see that the -1 doesn't print out. That's one of those situations, and we talked about this in a couple modules in the past. We're sort of putting a band-aid over a problem here. Yes, the printout is correct, but that printout's correct because we're not printing out all the numbers that are in the array, which seems sort of counterintuitive. The best solution here is just to not have the -1 in the array at all. But the only way to do that is to not actually read the number the user types in into the array, and instead put it in a temporary variable. So what I'm going to do is I'm going to create another variable called input. I'm going to read the value that the user types in into input. And then I'm going to check to see whether that input is something that I should put in the array. So if input is not equal to -1, that means it's something that should be going into the array. And I'm going to say count, or a count equals input. And I can just do the ++. That'll be simpler. Now there's two values to this. One is, first of all, the -1 that gets read into that input will never appear in our array at all. It's also that I'm not incrementing count. unless the user types in a value that's not -1. So when the user types in -1, count won't be incremented, meaning I can now print out the full count of these variables. The other benefit is that my while loop becomes much more simple. Input always holds the number the user typed in. Sometimes input is copied into the array, sometimes it's not. But the while loop can always look at input. So we can do something like this. Now that's the final format that we were going to go through to read something in. And it's worth, this format is worth really spending some extra time thinking about and understanding how we arrived at this. Using that separate variable is very important. It's going to relieve you of a lot of difficulty and a lot of awkward kind of comparisons and while loops than as compared to trying to read the input directly into the array. Now, if I run the program now, I get the same exact results. And I still have everything printing out except -1. But my loop is sort of rational. It prints out 0 up to count. Remember, count is one unit larger, or one integer larger than the element number that has the last element. Right? So it's a nice standard for loop, and this is going to be our standard input. And if we want to evaluate whether this input should go into the array based on something else, maybe a range of numbers, it has to be the number through 1 through 10, we would include that also in this if statement. All right, so the second part, this is our standard input loop and standard output loop for reading partially filled arrays, honoring and looking at this count variable. Our next job in this program is to start asking the user for numbers. So I'm going to have another do while loop that stops at -1. But this time, instead of adding those numbers into the array, I'm going to search the array and decide whether or not, or find whether or not the number's in there. So let's kind of think this through a little bit. We've got, in fact, let me copy some of the source code so we can kind of watch this all happening. Okay, so we've got our array A, and I'm not going to write all 15 elements here. 1, 2, 3, 4, 5, 6, 7, 8, and we know that that goes out to 14 if A is size 15. Right, and we've got count. And as this starts to work, if the user, let's say the user types in the number 3, count goes from 0 to 1, and 3 goes in here. The user types in 7, right? Count's going to go to 2, 7's going to go in here. User types in 5, count will go to 3, 5 will go in here. And let's say the user types in -1. We're going to say input not equal -1. Okay, that actually is false, so we're going to skip this. We're going to skip this statement, and we're going to stop. So count will set at 3. We'll have 3, 5, and 7. So now, let's say the user we ask the user, okay, we'll type in some numbers. Let's say the user types in the number 7. Well, how do I go and search this array? Well, I can visit, just like I print, and let me go get the for loop for a second from Visual Studio. Right, so I brought that code in. If we look at this for loop that was printing out each element, the for loop started with an I value of 0, so it started here. It printed out element 0, A0. It did I++ that moved it over here, and then it checked to see whether I at 1 was less than count, and it is. So it printed out the 7. It did an I++. It printed out the 5. It did an I++ to get I equal to 3. 3 is not less than the count, because it counts 3, and we stopped. All right, well, just because this for loop happens to print things out, it doesn't need to, right? So if we take this statement and we change this to something like if AI equals the number that the user typed in, so let's call that search, then we found it. So we can walk all the way through and visit every single element just like we did, but instead of printing the value of the element, we're going to do an if statement. We're going to say if AI is equal to the thing we're searching for, we found it. Now let's say the user types in 9. Right? If the user types in 9, we're going to run through this for loop again. We're going to visit each one, but notice that at no point in time is AI going to equal search. I don't have 9 in here. But eventually the for loop will stop when we get to this location. Meaning after the for loop, we know that if we have not found the element, then it's not found at all. Right? So what I'm going to do is I'm going to have like a Boolean value, a flag, say found. And I'm going to initialize it to false. And now I'm going to write, I didn't really write any code here. Instead of, printing anything out, what I'm going to do is I'm going to just say found equals true. So I'm going to start found at false right ahead of time. So this is exactly the way my code's going to look. I'm going to declare a flag called found, initialize it to false. I'm going to walk through the array. I'm going to walk through each element, visit each one, decide whether or not I found the element. If I did, I'm going to set found to true. Down here, I'm going to just write an if statement that checks, have I found it? If found is true, it means I saw the value that I was looking for. I'll print out, yes, you found the number. If found is still false, that means I never went into this statement. I never found anything. And I'll print out, no, it was not found. Right, so this is called, and it's a common technique. It's called a Boolean flag. Right? Flag in respect to, it's basically just a switch that you walk through a loop and you flip the switch or you turn the switch if you find what you're looking for. And then after you're done walking through the entire array, you then reevaluate, hey, did I find what I was looking for? It takes some practice to start to think about this because we're not actually going to really report anything when we find it. We're gonna wait until we get through the entire array to report that we found something, which is a little unintuitive the first time you see it. All right, so I'll take this out. I don't need it, and I'm gonna say, let's do a do while loop, and I'll reuse the input variable. So while input is not equal to -1. And I'll say enter a number to search for. I'll read an input, and then if it's not -1, if input is not -1, I don't want to search for -1. I'm going to search. I'm going to start to search for input. So to do that, just like I wrote down before, I'm going to have a Boolean flag. I'll say int found equals false. I'm going to write a for loop that goes and visits each value or each element in the loop up to count, not including count, I++, same for loop as the print statement was. And now I'm going to say if AI, if the value at that location is equal to the thing that I'm searching for, which is input, I'm going to say found equals true. After the for loop, it's either going to be true or it's going to be false. If it's false, that means I never found anything. I walked through the entire loop and I never found it. If found, and I can say if found equals true, but that's not really necessary. Found is either true or false. It's a Boolean value. The if statement requires a Boolean expression. We normally don't say if and then just an integer or just a double, but a Boolean is perfectly acceptable. So if found, cout, yes, the value exists. else we'll just say I couldn't find it. Okay, so let's give this a shot, and we still have some issues that we got to take care of with it, but it's getting close. I'll type in my numbers 5, 7, 4, 3, -1. Let's search for the number 4. Yes, it exists. Search for the number 5. Yes, it exists. The number 9 does not exist. That's good. And I can do -1 to stop. Right, so we're looking good. One thing that we sort of said we were going to do, but I never went back and did, what happens if I keep typing in a lot of numbers? And I don't know how many of these are. Maybe I should have done them in order here, but we're getting to the point where this is a lot more than 15. And that actually presents a real problem because we're going past the bounds of the array. Things sort of work, but we're actually getting a lot of corrupt memory here. So I need to make sure, as I said, and we can see that actually once I do start to close down the program, that corrupt memory error does start to crop up. I get a runtime check that the variable around A was corrupted. What that's essentially saying is that you've blown through the variable A. The variable A is an array. You've gone way past the bounds of the array, and we've finally detected it, and we're gonna throw an error. So the error could happen right away, it could happen at the end, but nevertheless, there is a programming problem here. All right? I don't want to allow the user to type in more than 15 numbers. I can fix that. That has nothing to do with the search, really. But you know, that has to do with the input. Right? And so when we were reading these numbers out from the user, we checked to see whether they were -1, but notice that we continue to ask the user for more numbers while they don't type -1. We don't say anything about the 15. So what we can do here is say while the user hasn't typed -1 and the count is less than the size, or let's put 15. And I kind of gave this away. As soon as I write that size twice, I really should think about doing a constant and using that instead. And that way I can change the program a little bit more easily. In fact, so I can save some time here, I'll set this to 5. Now, let me build this again. Just make sure that worked. Now, when I run the program, I can type in a few numbers. Everything works fine. It stops at -1. I can also type in 5 numbers, and it automatically stops. And that's exactly what we want. And the search still works the same way. Okay, so the last part of this was, instead of saying yes or no, could we figure out how many times the number is present in the array? So if I type the number 5 like 4 times in the array, can I actually detect that and say, well, yes, the number exists, and it also exists 5 times? Now that's actually a fairly easy change, because I've got this Boolean that says yes, I found it or not. And notice that if I go through the array and I find the number 5 4 times, for instance, I just keep setting found to false. And I'm never, by the way, I'm not saying else found equals false, right? That would be really bad, actually, because then in that case, either found is going to be true or false always based on the last element. I'm going to walk through, and the last element I visit, it's either going to say set found to true or false. I don't want that, and that would not have been the correct solution. If I find it, I mark it true. I initialize it false, so by the time I'm all the way through the array, if I never found it, found is still false. That's a very important distinction. I'm not setting found on every turn of the for loop. I'm only setting found if I find it. Now I'm going to change this a little bit and say num found instead, and I'm just going to make it an integer. I'm still going to say 0 now, and say basically I'm assuming I haven't found the value. if I find it, I'm going to say num found plus plus. I found it once, I found it twice. As I go through this for loop and I go through that array, I'll find this number maybe several different times. Now, instead of saying if found, I'm just going to say if num found is greater than 0, yes, the value exists. And we can print out num found times. So same basic pattern, but instead of just keeping sort of a Boolean yes or no, now I'm keeping a count of how many times I found it. And of course I didn't call it count because I already had a variable called count. So if I run this again now, if I type in 5 twice and I search for 5, I'll find it 2 times. If I search for 4, I'll find it 2 times. If I search for 6, I'll find it once. And I search for 8, I will find it no times. Now, the next module, sort of the lead into the next module, if we look at this program, it started to get kind of big. And we've got this functionality here, right here really, that's searching through and trying to find an array. Ideally, we would try to start to encapsulate some of this logic into functions, because searching an array is going to be a very common practice. So one of the first things that we'll do in the next module is start thinking about how we can use functions at the same time as arrays. Clearly, if we were to write a function to search for this input, we'd have to pass this array in as a parameter, and that's what we're going to focus on in the next module.